Hello, my name is Jamin Eisenberg, and this is my Discrete Structures Final Project Phase 2. Our problem is to prove, using induction, that 9 to the n minus 1 is divisible by 8 for all positive integers n. So first, I want to talk about this notion of divisibility by 8. If you think back to elementary school, you could tell if a number was divisible by a certain other number if the number you have could fit into a certain number of circles. So we have 8 circles here, and we have 8k, which we want to prove is divisible by 8. And I think it shows it quite nicely when you put k into each of 8 circles. So for the sort of belief phase of this project, I wrote a program to go through certain n's, and for each of those n, compute 9 to the n minus 1, and then ask if that result is divisible by 8. And you can see the results on the right-hand side here. So we say n is 1, 9 to the n minus 1 is 8. Is 8 divisible by 8? Absolutely. Seeing that our given property is true for the first 100 numbers makes me believe that it's true for all numbers, but of course we have to prove it. The inductive hypothesis in general says that some property P holds for all numbers n with some constraint of n. In our case, our property says that 8k equals 9 to the n minus 1, where k is just some constant, and n has to be greater than 0 by the constraints of our problem. So this is the thing we're proving is true for all positive integers n, is that 8k equals 9 to the n minus 1. This is our property. This problem is solvable using weak induction, so we only need one base case. N being greater than 0 means that our base case must be n equals 1. When n equals 1, our formula becomes 9 to the 1 minus 1, which is of course 8, and 8 is trivially divisible by 8. So our inductive step, as defined by mathematical induction, is that 8 times some constant equals 9 to the n minus 1 implies that 8 times some other constant equals 9 to the n plus 1 minus 1. So on the left-hand side, we have our property for some n, and on our right-hand side, we have our property for some n plus 1. So if we can perform some operations on the left-hand side in order to get the right-hand side, that means that the left-hand side implies the right-hand side. So let's do that with some algebra. So the first line here is just our property. 8 times some constant equals 9 to the n minus 1. Now, in the next step, we simply add 1 to both sides. And in the following step, we multiply both sides by 9. Remember that our goal is to get this thing that we started with to look like this thing on the right. So we're trying to get a 9 to the n plus 1 somewhere in here. So we multiply both sides by 9. And in the following step, we distribute the 9 on the left-hand side, and 9 times 9 to the n is just equal to 9 to the n plus 1. Now, this next step is probably the biggest jump. We have 72 times some constant is the same thing as 8 times some other constant. So remember that the 72 is just 8 times 9 times some constant. We know that 9 times some constant is just some other constant, so we can say that this expression is the same as this expression with a different constant k. And we split this 9 up into 8 plus 1. So this plus 8 is just sort of absorbed into this multiplication and becomes 8 times some other constant. And again, the right-hand side is left unchanged. And finally, we just subtract 1 from both sides, and we get our right-hand side from the previous slide. 8 times some constant equals 9 to the n plus 1 minus 1. So if we go back to our inductive step, that proves that this side implies this side, which, according to the definition of mathematical induction, actually means that this property that we've defined is true for all positive integers. And that gives us our answer to our problem. Thank you.